back to basics. I started a course, Computer Architecture by Onur Mutlu. I've done this course in the past, and I'm doing it again because it's a refreshment of the course. The course I did first was from 2012. Now I'm doing the one from 2020. Onur is one of my go-to professor when it comes to computer architecture, computer design, software design, algorithms, all these types of things. He is an incredibly creative person. He's an interesting person, inspiring, all these things. And the reason I'm doing this course is just to refresh, to see what's new, what are ideas that are being communicated. And of course, the question comes up, well, why is a hedge fund manager doing a computer architecture course in the first place? And the answer is, we at Orange Capital Partners, we believe in creating wealth by investing in fundamentally new concepts and engineering practices. We do focus on computing. In other words, we believe that wealth is best generated by using computation to explore counterfactuals and solve problems that way. In other words, we believe that innovations in computing will drive innovations in business and engineering practices that fundamentally will instantiate themselves into products and services that we can then use as customers and invest in as investors. We also believe that Onur is the type of person that can give you a bit of a just inspiration of where the future is going. For example, he's talking a lot about genomic research. And if somebody like Onur is talking about genomic research, then that is even more interesting than, let's say, if a biotechnology person talks about it, because this is not really his field. The reason he's interested in the field is because there is an application of computational solutions to the field of genomics that could be very interesting. And that to us in hedge fund managers is incredibly interesting. Finally, I just want to, again, for new listeners, at Orange Capital Partners, we talk a lot about what we read. This is now even deeper. This is a course that we're taking. It's an online course. We're taking a course. It's the Polytech in Zurich, where Onur is now professor, and he's offering this course online. So we encourage anybody who's interested in the future of computer architecture to listen to this course. But more importantly, the purpose of this podcast is to give people a sense for what it feels like to run a hedge fund. And running a hedge fund is fundamentally the problem of running a hedge fund is you have to see the future, and the best way to see the future is to look at where is innovation and computation going to happen, because we believe that the future will be driven by new applications in computation. This is the Not Even Wrong podcast. It's April 28th, 2022. This is Krim Telco. For the day, the fund is down 40 basis points. The market's up 2.3%. We are down for the year 26.6%. The market's down 10.2%. We're underperforming by 16.4%. Unfortunately, Tesla is still suffering, taking a hit from the Twitter overhang. And we will not talk about this in this particular episode. This particular episode is for Onur Mutlu's course. We will see how this will evolve. My goal is to maybe do lecture by lecture. So a little bit like in the tradition of Brad Hall when he does chapters of books, we might do lecture by lecture. Maybe we won't do every lecture. This is a relatively technical course. There's a lot of things that we don't necessarily care about, in a sense that we don't need to talk about very, very deeply technical things about microarchitecture of computers. What we want to do is keep it at the high level, because this is really what we care about. So first and foremost, what is computer architecture? Is the design of software, algorithms, and devices and logic and all the things along the stack that we need to translate the solution to problems into electrons, because this is really what computers do. What computation does today, the way we understand computation in 2022, is that we have a problem. For example, we want to have a self-driving car, and we want the electrons to actually drive the car. This is really what we're doing. And the way we do that is by designing algorithms, which is the top. Then we transform those algorithms through compilers into some sort of machine-readable language. The machine-readable language then communicates with a microarchitecture level in the hardware that is able to read the compiled program, and then the microarchitecture starts implementing the instructions into the actual hardware. And then finally, the devices that we use, in a sense, for example, the processor that eventually drives the car, then is being driven by the electrons, which are manipulated through the algorithm and the whole stack in that way that the car drives. So this is what computer architecture is on a big picture. And Onur's lecture is incredibly inspiring because he really has this ability to give you the big picture view and then also give you the details of technology. In other words, what I'm trying to say here is that, and this is now a little digression, but I'm going to indulge here. A lot of times, okay, there's a funny TikTok out there which says that, oh, I study computer science, and then the way I imagined it is, and then they show Tesla, SpaceX, and I don't know, financial markets, and you know, masters of the universe. And then there's the reality of computer science, which is some person that has some sort of accent, and he says, you know, the internal variable is this, and blah 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 blah. Basically, what the point of the TikTok is to show how actual boring computer science is, and how the actual work, daily work of a computer science student is incredibly boring and not what you expected. And my point here is that it doesn't have to be like that. And Onur is a great example for that. It really doesn't have to be like that. Onur starts with big picture problems, for example, genomic research. And then he explains what are the problems of genomic research. The problems of genomic research right now, as we know it, is that we need to read the genome. The way we read a genome is that we compare whatever we read, the sequences, so what, let's say PacBio or something like that is reading, and then we need to compare it with a sample and then say, okay, is this genome X the same like genome Y, and if not, what are the differences? So for that type of problem, we have certain types of algorithms which need to compare billions of base pairs, and there's certain ways to transform that algorithm onto hardware and so on and so forth. And like you can hopefully already see that this whole problem now is starting with a practical problem and then reduced to, okay, how can we solve this in computation space? So we have real space, computation space. And I think this is what's so powerful about Onur. And this is, again, the digression will be my suggestion for any kind of education, that we do education that way instead of doing it the way it's done now, where we learn abstract things and then we don't even know what they're used for. For example, my son today is doing trigonometry in school, in high school, and he's asking me, well, why am I doing this? Well, why do I need to know this? Well, why do I need to express stuff in radians? And I feel bad because I'm like, listen, you can use this, for example, when you fly to Mars, you need to understand trigonometry, and when a self-driving car drives, he's using radians to manipulate the steering wheel and things like that. Why don't we start with a problem and then solve it, and then also offer solution, and through that also learn about basic concepts. But anyway, this is the digression. I don't want to go into more details here. Let's get back to Onur Mutlu's course. So in today's episode, I just want to sort of introduce the course. I want to talk a little bit about why we're doing it and why some of the basic insights we're already taking from the first, let's say, 1/3 of the course. From the first 1/3 of the lecture. The lecture is 2.5 hours, and we've done about 1 hour of the lecture so far. So again, motivation for the course is we read reading is not just a pastime of a hedge fund manager, it is the business of the hedge fund manager. And sometimes we read books. We just finished The Grapes of Wrath by John Steinbeck, which is a book, a novel, and reading can also be taking a course. Why are we doing computation? Because we believe that computation is the future of, at least for business and science in general. Like one of the big inspirations that the course already offered us is that Onur talks about a lecture that Richard Feynman gave in 1959 at Caltech, where he says there's plenty of room at the bottom. What does he mean? He says that, look, we can talk about high-level concepts such as algorithm, software, computation, but we can also talk about how can we manipulate atoms, how can we manipulate stuff at the very, very bottom in the very small space. How about we do some research there? It's 1960. Today we have things like quantum computing, which is directly inspired by Feynman's lecture. And I think applying to our own portfolio, of course, Tesla is a big proponent of this idea where we're saying, look, we can build a self-driving car by delivering, let's say, good software and algorithms, but we need to talk about sensors, and we need to go all the way down to the actual processing level. That's what Tesla did. They built an accelerator or an application-specific device that is what they call a chip that is within Tesla. And Onur actually talks about this particular chip. He mentioned that in his introduction to the lecture by explaining that general purpose computing today isn't working anymore because we have this incredible need for specific workloads that are new and very exciting. And actually, the two workloads that Onur is specifically pointing out in the beginning of the lecture, one is self-driving cars and the other is genomic research. And interestingly enough, both of these workloads are exactly the kind of things that we have invested in at Orange Capital Partners. Now, this gives us a lot of confidence that we're hopefully on the right track here, and we in a sense that what we're trying to do is, again, generate wealth by investing in fundamentally new concepts and engineering practices. Now, why aren't we investing in quantum computing? Because maybe those workloads that are possible to quantum computing, we're just not there yet. We don't even know what we don't know. We just probably need some more time. However, self-driving and genomics is at this, Goldilocks where we have the problem, we understand the problem, we have some ideas of the solution, and we have abilities to deliver hardware, devices, logic. So across the whole stack of computer architecture, we have the ability to actually do something that could instantiate itself in products and services, which in the end ends up being a business, and that's how we generate wealth as investors. So I would say that's the beginning of the lecture. I will continue with the lecture, but for now, again, the summary is, again, why are we doing this? Because we encourage people. The purpose of this podcast is to give people a sense for what it feels like to run a hedge fund. Please, if you want to run a hedge fund, you cannot go around this. You need to read, you need to educate yourself, you need to continuously scan universities, whatever university, it doesn't matter, it doesn't have to be Stanford or Caltech or anything like that. It could be your local university, but just look what academics are doing, look what the latest cutting edge thinking is in whatever area you're interested in, and then try to understand, okay, is this area enough developed that we can now start engineering solutions to problems in the real world, because that's where you're going to generate the wealth. And I think Onur is phenomenal at that. I recommend again, is not just an interesting person in terms of learning about the actual subject, but he also has this ability to just give you a little bit of a big picture of where the world is going and to get a bit of a sneak peek into the future, because computation is going to drive the future. Thank you.